if the Earth is here, we got to figure out where the stars are. Now, ignore this picture right here. Ignore this model. Right now, which direction are the stars? Don't overthink this. Which direction are the stars? Which way would you have to point them out? Up. Somebody said out. That's basically the right idea. They're up, right? They're up. But remember, because the ancient Greeks knew that the Earth was round, and they knew that no matter where you were standing on it, up would point to the stars. That means the stars are out in all directions here. Okay, so there's going to be stars surrounding the Earth. Now, here's the problem, though. Okay, let me see if I can simulate this. Okay, here we go. I got a thing. Here's the thing. Here we go. Here's the thing. Right now, based from my point of view, this thing is up, right? This thing is up. Okay? Let me kind of get this going on. Here we go. This thing is up. All right? Now, if I let go of this thing, what's going to happen to it? What's going to happen to this if I let go of this thing that is up? Whoa. Oh no. Here it goes. Oh no. It fell on me. And actually it fell over on the document cam. There you go. So things that are up because of gravity come down. Okay? Anything that is up comes down. And where are the stars? They're up. So based on that line of logic, what should the stars do? What should the stars do if they are up? What should happen to those stars? Yeah, those stars should fall, right? Those stars should come down. Now, we know that the strength of Earth's gravity gets less and less as you go away from it. If you go just a little ways out from the Earth, you're not going to feel much gravity from the Earth, right? But the ancient Greeks, they wouldn't have known that. They've never been to space, right? They didn't understand how gravity works. So they thought that the Earth's gravity went on forever, okay? They thought that no matter how far up you are, you're going to fall at the same rate, right? So yeah, they thought that the stars should fall, okay? So they had to come up with a reason that the stars don't fall. Remember, they're trying to build this up using logic, right? And this all makes sense, even though there's parts that are wrong. So check it out. If I wanted this thing to stay up without me holding it, I have to attach it to something, right? Like if I threw this ridiculously hard, I could lodge it into the ceiling of my room. Right? I could just jam it up there into the ceiling. And if I just jam it into the ceiling and let go of it, it would stay. I'm pretending right now, okay? Now, okay, check this out. With this logic, if I jam things into the ceiling, they don't fall down. What did they decide was the situation for the stars? Why don't the stars fall down? Okay, why don't the stars fall down according to the ancient Greeks? Let me walk it up. Remember, we said things that are jammed into the ceiling don't fall down. Why don't the stars fall down? Yeah. They were stuck in the ceiling, okay? The ancient Greeks decided that the stars were jammed into the ceiling, okay? They were jammed into the ceiling. I know you might be asking yourselves, the ceiling, what are you talking about? Well, the ancient Greeks decided that surrounding the Earth in all directions was a giant ceiling and that the stars were all attached to that ceiling. So these little dots are stars just hooked into the ceiling. Okay? And they called that ceiling the celestial sphere. You love this class? Thanks. I like this class too. The celestial sphere. And it was held in place by the Earth's gravity pulling it in from every direction. Because the Earth's gravity pulled in from every direction, it could hold this in place up there. So yeah, the reason that the stars don't fall down is they're attached to this thing, okay? Now, here's the thing. The stars rise and set every day. Like if you watch the constellations, they're going to come up and they're going to go across the sky and they're going to set again. And we have to come up with a reason, us ancient Greeks, we have to come up with a reason that happens. What would be one way that you could make the stars go across the sky every day based on this? Well, one way is to have the Earth rotate once every day. But there's another way you can figure it out. What else could be happening? What could make the stars go across the sky other than the Earth spinning once a day? What else could happen? Going to give you guys a couple of chances here. Yeah. So the other way, the other thing that could be happening is that the stars together are rotating because the celestial sphere is rotating. So either the Earth rotates once a day or this rotates once a way in the opposite direction. It would make the same pattern in the sky. Or it could be a little of both, right? It could be one of them turning one way and the other turning the other way. But which one, based on everything that we've said so far, which one did the ancient Greeks probably think was actually rotating? Did the ancient Greeks think that the Earth was rotating once a day or the celestial sphere was rotating once a day? Which one did they think was happening? Which one was spinning? So remember, it's the sphere. It's the sphere, okay? Remember, why did the ancient Greeks decide to go with the geocentric model in the first place? Because they couldn't feel the motion of the Earth, right? And if the Earth, they knew the Earth was really big, so they knew that it would have to spin really fast, or it would have to spin, the surface would have to be moving really fast to get around in one day. And they didn't feel that, right? So they decided that it must be the sky that's spinning, okay? The celestial sphere is spinning once a day. However, okay, remember the zodiac. So this celestial sphere here is just covered in constellations. The whole thing has constellations all over it. And those constellations are locked in place on the sphere. The whole sphere would rotate, but the constellations are locked in place. The zodiac, that's the constellations that the sun passes through, okay? So even the ancient Greeks knew that the sun moved through the constellations, okay? Now, if the sun moves through the constellations, can the sun be locked in place on the celestial sphere? If the sun has to go through the zodiac, can the sun be locked in place in a certain place on the sphere? No, that's right. No, the sun can't be locked in place. But does the sun fall on us? No. So the sun can't be attached to the celestial sphere, but it also doesn't fall on us. So can you guys figure out how they addressed that? Where is the sun gonna be? What did they have to add to this to make the sun work? See if you guys can figure that one out. We need the sun to not fall on us, but it can't be attached to this. What do we got? Another sphere. Yeah, some people say another ring or another surface. Yeah, they added another sphere inside the celestial sphere and attached the sun to that. This sphere was not called the celestial sphere. I'll just call it the sun sphere. And it spun at a different speed than the celestial sphere did, right? And because of that, the sun was able to go through constellations as it went through the sky, right? And this sphere, though, it couldn't be the same color as the celestial sphere. Because check this out. What color is the celestial sphere? What color is the celestial sphere? What color is it between the stars? See if you can figure that one out. What color is the celestial sphere? Not the stars, but the space between them. Yes, it's black. The celestial sphere is black, okay? So why can't the sun's sphere be all black? So why can't the sun sphere be all black? Why would that not match with what we see? And by the way, while you guys are answering that, remember that all of this is not true. This is just how the ancient Greeks thought things worked. We now know that all of this that we're drawing is not right. So yeah, the sun sphere can't be black, because if it was, it would block our view of the stars, okay? The sun sphere can't block our view of the stars. So that means that the sun's sphere has to be clear, okay? It has to be clear. And you have to be able to see through it, in other words, to be able to see the stars. And so they decided that the sun's sphere was probably made out of something kind of like glass, okay? Or quartz, or some kind of crystal, right? That said, the ancient Greeks, because they were good scientists, they did not say that this sphere was actually made out of crystal, okay? Because they knew in order to prove that it was made out of crystal, they'd have to go up and touch it. And they had never been there. So they just said, based on how it looks, I think it's made out of crystal. So that was a hypothesis, okay? Now, that said, the sun was not the only thing that had to have its own sphere, because there was another thing that moved at its own pace. Anything that moves at its own pace has to be attached to another sphere in this system. What else had to get its own sphere? Yeah, the moon. So they attached another sphere in here. And had the moon on that sphere. All right? And the celestial sphere and the sun sphere and the moon sphere all spun at slightly different rates. And based on this system, you can actually get pretty good at predicting where the sun's going to be and where the moon is going to be on different days of the year. So even though it's all wrong, you could actually make some accurate predictions from it, okay, if you map it out pretty well. But here's the thing. Over time, they got better and better and better at mapping out where exactly the stars and the sun and the moon were on different days of the year, okay? And when they did that, they realized with their more accurate maps that there were a few stars, maybe just a handful of stars, just like 4 or 5 stars, that moved at their own speed. They didn't stay in a constellation. They moved across the constellations. And so they came up with a new word for these special stars. They used an ancient Greek word for wandering star. And that ancient Greek word was planeta. So can anybody guess what these wandering stars actually are? These special stars that moved on their own that they called planeta? What are these things really? Yes, the ancient Greeks discovered the planets here, and essentially they thought that they were stars, because what do they look like to the naked eye? They look like stars, okay? They look like stars because they're so far away. The only way you can tell any difference is that because they are actually closer to us, we can see their motion, right? But what that means is that they gave special spheres to the planets too. So every one of the planets had to have another sphere in here. Sorry for my drawing here. It's just going to get worse and worse. Each one of the planets needed another sphere inside there, okay? There's a picture from your book that's a little bit better about this. Let me see if I can bring that up. Here you go. So right here, we've got the Earth in the center. If you look somewhere out, one of these is for the sun, one of them is for the moon, and the rest are for the planets. And all of these spun at different speeds around the Earth, okay? Now, check this out. Adding that in, they could pretty accurately predict where the planets were and where the sun was and where the moon was going to be on different days of the year. But over time, they got better at mapping the stars. Again, over time, as maps of the stars got more accurate, they would realize that their old system wasn't matching up as well, right? Every time they got better at mapping the stars, this old system didn't match up very well. So what they had to do is every time they got better at mapping the stars, they had to tweak the system to make it work, okay?